Alright, welcome back to the physics classroom here. So, I am explaining my pendulum lab and what I decided to go with. So, what I decided to go with was a little lab like this where I have pencils set up. I found a compass globe here, which was pretty nice because it acted like a mass, like a circular mass that I thought was needed, and it looked pretty good. It was very useful. And then I also use fishing line to connect it, and books as like the counterweight and everything like that. So when like trying to think of my pendulum lab, I first thought of like Newton's cradle, just because that's like the first thing I think of when I think of a pendulum lab, except not with multiple balls, just one. So and I was only using one string rather than the two that Newton's cradle uses, and I was trying to recreate that as best as possible. So am I um, thinking about it? What I decided to think about too was like a popsicle bridge. It's like what we do in previous physics classes or like robotics classes. And what we did is we had two pencils or like two popsicle sticks as like a support, and I was thinking I could like build a bridge out of it, or pretending to build a bridge. So all in all, what I did, I took two pencils, I set them on my desk about halfway. I put the books on the second half of the pencil that's on the desk already, just to act as a weight for that. So anything on here would be a counterweight, but would not be as heavy as this. If Kaiser, you're watching, calculus is indeed the way to go here. Just want to throw that in there. And then for here, for the third pencil, what I did, I just laid it across both pencils so it was equally displaced across both pencils. And then I tied the fishing line in the middle of the pencil so it would be equally dispersed weight or mass throughout the system, throughout the entire system. And then I tied the compass globe to the fishing line, and then also tied another line here, like a loose end, so I can use that later for our trials. Um, some changes that I made to make it more consistent and valid in the system is when I first tried and I let go of the string and went back and forth, the pendulum did, or the globe. This top pencil, right when I first dropped it, let's see if I can get the string here. When I first dropped it, the first motion of the pencil would always be in the same direction because of the momentum. So what I did is I took glue and I just put one like pea-sized glob glue here and one pea-sized glob glue there, and I just let it wait till it dried. So the pencil was sturdy and stable, so that no matter what, the pencil wasn't going to be able to slide. And the fishing line is tight enough, and the globe is not heavy enough for the fishing line to slide on the pencil. And so I moved the pencil and like the fishing line pencil all the way closest to the desk, but I have it not touching my desk just because it's more stable on the pencil's end, on the two supporting beams, rather than just on the outside because it's less sturdy there and less room for error if it's the pencil's closer to the desk. So what I did is on my phone I have the Clinometer app because I used it for physics last year for Six Flags. So I just use the same app, and yes, I still have the app. What I did is I just put my phone, the side of it, next to the fishing line here, and I was parallel to it, so that whenever I moved the globe, I would just move my phone with it, and so I can tilt it to wherever angle the fishing line was at. On the Clinometer app, there is a locking device on the degree, so it would read the most consistent number that you're reading at that time, and it just keeps shifting until you lock onto a degree. So with that, I could change this angle here, and then I would change my phone angle, and then I got to be consistent at 9.1 degrees for all trials. I know that I wanted it to be under 15 degrees because in the book it said that under 15 degrees was the most precise and accurate. And so I didn't want to push the boundaries with that, so I decided to go about 10 degrees, or shoot for 10, or a little around 10. And I finished with 9.1 degrees on all trials, like I said. I did multiple trials just because of consistency and systematic errors with if I had dropped it, sometimes the line would actually hit my desk, and so it started to create like an ellipse, something like that, and that is something I didn't want as a trial, so I discarded that number. And there was a couple times where timing was an issue because I had to do everything by myself. So that was kind of an issue. Um, so yeah, so when I raised this up, I got locked on 9.1 degrees, and then when I let go, I would time it 1 period, and I calculated, or I used the equation. Um, the equation I used was t equals 2 pi times the square root of L over G. That was the one that I used. So the length I just measured with a ruler in centimeters. I converted it to meters. G is what we're calculating, and then T was the period that I was trying to find. And so what I did is when I got it measured up, I would hold it still, a lot steadier than this. Go on my phone, change it from the clinometer app to the stopwatch. And so when I let go, I would time it from when I let go, when it came back to the leftmost point. And I got about 0.9 seconds for most of my trials. That's what the average came out to be. And then with that, I got experimental G value of 9.63 meters per second squared. And then that came out to have a percent error of 1.73. 1.73% error, as my theoretical is 9.8, as that's what gravity is. And my results are they are acceptable and reasonable, considering the limitations. Just because I try to keep everything most consistent with keeping myself who the timer was, who the measure was for the angle, doing the measuring the same way, keep measuring the same angle, like going on this side all 3 times and not switching to this side and measuring this angle. And then I tried keeping the stability the same. I did all 3 trials, or I guess all the trials at the same time, and so everything was consistent here, so nothing was messed around, and so there could be like a time delay where something got bumped. Everything was consistent with that. I used the same globe, same distances for everything, make sure that everything was the same throughout all trials. Although I did have a percent error, even though it was small, I just still did have a percent error. So if I could change it, or change one thing about my lab, I would try and come up with like a device or apparatus that could keep it from going in the pendulum in a different direction. So like here it's going back and forth straight, but sometimes it would start to curve around or start to go in an ellipse fashion, and it may hit the desk a couple times. So I could move it away from the support beams, but I was thinking maybe I could create something else that could make it more stable but less prone for error and with friction and everything like that, so keep it away from friction. But all in all, that is my video. So thank you, youngins, for coming to class today. Have a good rest of your day.